Yeah, so the first thing we are going to go through today is the economic analysis from situational awareness, and I think the last time we kind of coded by the PCD comic. Yeah, so what's going to follow in the next 15 to 30 minutes is an elaboration on this plot, and what this plot is telling us that if we continue to throw compute at the problem, then maybe something interesting will happen because it used to happen in the past. And just another thing I wanted to highlight. It's a unicorn. Right. So yeah, another thing I wanted to highlight. So you have a capabilities line, and the question is, where are you on this line? Right. So now let's get to slightly more serious stuff, maybe. So experts have, I think, consistently underestimated some kinds of recent AI progress. This is in particular breaking some particular data set, which is a data set of math problems. And there is this basic narrative that benchmarks are quickly getting saturated by frontier AI, and that is true. And this is something I notice in my daily work, as the benchmarks I'm using today to evaluate with Llama, literally have in the abstract, the previous benchmark was saturated by this frontier model, so we tried to come up with a new benchmark, this adversarial filtering on this exact model. And then what the author wants to propose that often you have some effective compute you throw at the problem, and you can effective compute can come in terms of direct hardware, you spend 10 GPU hours versus 100 GPU hours versus 1,000 GPU hours and so on. I'm getting some weird allergy, so sorry for my tears. It's not me being tearful at the pace of AI progress. Or they can come in terms of algorithmic improvements. Sometimes your training algorithm is stupid, and even if you have 10 GPUs crunching on the problem, only you only get 10% utilization. Or it can be something else, and we'll get to something else. And this is the Sora paper, by the way. Yeah. So, and then the narrative is that we're getting a lot of this effective compute improvements going on. Just throwing more compute is a problem going on. And here we see that each successive GPT of 2, 3, 4 used 100 times as much compute. And I was curious where these estimates come from, because OpenAI surely is drilling them. And there is a public, there's a non-profit, I think, which does estimates for this kind of thing, and they have a comprehensive database going to very recent stuff as well, and they have this chart. And what this tells us is that from 2010 to 2024, if you hit feed the regression, you can see that the effective compute grows at the pace of 4 times the like whatever is okay. So like we have some early computer vision saying, which is like just a puny 6-layer perceptron on NIST. And then we get AlexNet, which is the big breakthrough to ESON, and like as the progress continues. Yeah, like another few takeaways. So yes, I think like each of these is interesting to discuss. So like we see 4 times like flop improvement per year, and this translates to like 130% of cost increase per year, and people apparently care more about language than vision. I think because more obvious economic effects, maybe, not sure really. And finally, size of data sets. So this is again interesting because we are now at about the stage where we are out of data. All right. So yeah, it's this literal graph. Why is everyone like, why are people on Twitter talking about Altman investing into Cold Fusion? Because like if you continue investing if you continue investing 4 times as much per year, then you like eventually need something advanced because you like run out of standard things the same way we run out of normal data. Yeah, so another side of the coin is algorithmic progress, and I think this has kind of an this has some points. Great. So like first thing to look at here is that so like this 3 are if you were to train a model, like AlexNet is like a landmark model in deep learning, classic in give a caption for the image, so classify an image. And what this picture is showing us that with improvements in the way we train models, like with with optimizer improvements, with like data regime and like ability to calculate an optimal batch size. So this sort of thing improvements. In 2012, you needed like 10 to the 19th to like be here at the loss curve. Oh, wait, it's actually not the loss curve. To get, so we fix the performance, we fix accuracy, and to get to this accuracy, we can be 10 to the 19th and flops and 10 to the 3rd in data. And like to get to the same point on the curve in 21, you need like less than 10 to the 15th in flops. So this is 4 orders of magnitude in compute. And like this is basically the same along a few other popular models. Yeah, so like you fix accuracy, and you can see that you need less flops and less data, and you can trade off the two. Is that all right? Okay. So And like again, by external estimates, we can speculate something like this for LLMs as well. Oh yeah, like I didn't read Megatron, but like LSTM and Chinchilla both have like papers. They proposed entirely like algorithmic ideas, and those indeed like made gains in efficiency. And one way we can infer algorithmic efficiency for closed models is to look at API costs. And API costs for a given performance level have been falling steadily also. So some particular results are like, this paper doesn't really go into them, and besides mentioning them, but I just wanted to spell them out because like, so algorithmically optimizing model training and inference is exactly what I've been working on for the last few days, because I had to feed Bad Llama into like something small. And like, I can really see this. Like, you have like plain attention, and then you have flash attention. And like, your inference goes twice as fast for like losslessly. And then like Chinchilla scaling laws is that they found that the way that people previously traded off compute against data wasn't optimal. Like, you actually need more compute and less data to get better loss. And so like they just do that, and like they just get better performance for free by changing training regime. And then I don't know, you have something like continuous batching for inference, so that you use all the video RAM and not fix a particular batch size when your input prompts are of different size. And this is like, again, just a free engineering win. Like, you just utilize your hardware. And this is absolutely happening. Yeah, so, and this gives us this picture that like, if you just, continue the trend line using Excel's built-in, continue the trend, then like we have like this stacked plot where we have this much increase of physical compute and this much increase of algorithmic efficiency, and this contributes to this much effective what the author likes to call orders of magnitude, like effective performance, I guess. So is this all right?
Is it okay that there is no any scale?
I mean, yeah.
Okay.
I mean, so this is only here for the sake of intuition, and I don't think this has so what this write-up does is it gets us a bunch of hard data, or like somewhat hard data on a bunch of sources. So this is a kind of somewhat hard data, but I don't think it synthesizes it into like a concrete predictive model. It just like says that here we have like a bunch of sources which all point in kind of the same direction, and this is what this direction is. Okay. Yeah, so this interesting tidbit that apparently, Llama 3 was trained on 15 trillion tokens. The internet seems to be 30 trillion tokens. So it would seem that we already don't have this data to train on. What Leopold proposes we should expect a lot of investment in that. So same as in self-driving cars, people invest a lot in simulations, or like in Go, like Go models are trained with self-play. he proposes that we should expect a lot of work in this direction, like for this to be a major investment avenue. Yeah, and I just found this interesting. So he says that often, like many people work for a lot of time on a problem in deep learning, and then a very simple solution clicks. I'm not really sure what to make of it. I mean, it seems kind of true if you look at the architectures that make it, but I'm not sure what this implies.
Implies, like, he says later that implies that we can expect algorithmic progress. Like it's like a stochastic one, but we can expect.
Oh yeah, makes sense. Yeah, I guess like it's useful to kind of think of possible like reference classes. Like, I mean, it's not particle physics where we are blocked on experiments which are expensive. It's like it's letting 100 engineers into the room and like waiting till someone makes something that works. Yeah. Okay. Yeah, I guess like this is the takeaway. So if we say that the process is stochastic, then we should expect error bars on our forecasting. So I mean, if someone randomly stumbles on something, then we're good. If he doesn't, then we wait a few more years. And this is unlike like we are just building a collider, and then the collider gives us results. So I guess it didn't quite pan out this way in physics as well, but well. Okay, so we talked about physical compute, and physical compute is easy because someone builds a data center and buys this many GPUs and also NVIDIA reports like an earnings call, and this is easy. Algorithmic progress is also like all right because like everything ends up on archive, and like we can just look at archive. And the third fuzzy category of improvements is what he calls unhobbling. And this is, I think, what we normally call like harness design or like agent design or stuff like that, which is like trying to elicit the capabilities fully, something like that.
Cool hacks that work.
Yeah, and like these are very different. So like RHF is about like you have a model which was trained on the internet, and so like it has like it contains the internet in some way, and you want to elicit like particular parts. So like you want it to talk like a Stanford graduate and not like a random Reddit person. So it can do both, absolutely. Chain of thought is, I mean, our standard hypothesis is that it is just throwing more compute at the problem. Scaffolding is like throwing more compute at the problem. Tools are kind of, yeah, so we should expect tools to give us large domain-specific gains. Like, for example, if you're doing cyber, we should expect like giving like binary exploitation, like, you know, like a debugger and the fuzzer to give large gains. Simple. Context lens also clear. And I think this is just training more, so that's really count as unhobbling. And the interesting thing here is this plot, which shows how we get better over time as models get improved. And on the like the y-axis is success rate, and like what this really shows, I think, is that like you can what's that? So like if you go from here to here, this is like 15 if you're generous percent in improvement and 3% in improvement over baseline, and this is like another, say, 5% of improvement. Yeah. So if you're very generous about how you interpret this, then you can say that you can go twice as well with scaffolding. Very generous. And I think this is maybe underselling it a little bit, because like in some domains it clearly just won't work without like tools. And I think what he's saying here is that actually we are still very early in this unhobbling thing. And a particular thing he proposes is to, one is to have persistence, so like is to have like longer term context visualization, like I don't know, your computer has your context, but currently is model doesn't use it. Second is throwing more computers the problem, and
this is important also. Like they can mostly misexploit also there. Other person, I think that it's not really. It can be much larger task that everyone can do.
Yeah, I was actually just going to go back to that, I think, directly, because he has a section about that right here. Yeah. So he suggests that if we can figure out a way to effectively throw more computers the problem at inference time, we are going to be very good, because this table right here. So like because spending because like it would be great to live in a world where spending like 10 times as much compute gives us like a progressively larger version of the solution. And if this holds true at train time, then maybe it should hold true at inference time. And he gives some evidence towards this happening in other domains, like so in games, they basically show that you can like train the model for less, but let it do more inference at a particular game, and like trade this off. Yeah, so I think this could be pretty big, and this is also connected to the Mesa Optimizers paper, if anyone is familiar. Like if we if you train the models to perform for this kind of regime, you might expect them to do less memorization and more generalization at train time also. So this might be good. Yeah, like, was that clear at all?
Does that like practically propose that we have in like ChatGPT like chat interface like a slider, like spend 1 month working on this and we come back next month and we're like, is that the practical application of this?
Yeah.
Okay.
Yeah, so like you can imagine like I mean currently like currently this slider is always at one position, so yeah. There is like a particular category of tasks that works, and the more complex ones just don't. The idea is to be able to move the slider.
Yeah, there's a famous explaining what's the benefit paper that it's not intelligent if it always hard. So it should have a regime when we don't know if it helps or not. Yeah.
Great.
We don't know that like we cannot know. Yeah, but like a problem of housing.
Yeah. It's not intelligent
It's
if it has.
always yeah,
Yeah. Critical
but
perspective.
it's quite long, so
Okay. Right. Yeah, I think we're basically done. I just want to show you a few more pictures. Yeah, so like again on public estimates, we in the 5 years we had like, let's be generous and say 6 orders of magnitude improvement in like in effective compute from GPT-2 to GPT-4, and then a bunch of weird stuff which is hard to quantify. I think I don't know. I'm skeptical of this number, but I mean, so 6 order of magnitude improvement over 5 years. This we can believe. And so why not expect 6 more magnitude improvement in the next 5 years? And if we figure out this like slider thing, then this can be big, because this is literally allows us to like to say how many orders of magnitude to spend the problem. Yeah, I think this is the point. Is that all right? Okay.
and but when we hit the data hole, we want to like
Yeah. Yeah. A great point about the data wall. Like this is like the data wall is a great counter to why this might not pan out.
So what is stopping us right now from making this slider? Are these just some technological challenges?
Well, like with the current model design, you quickly hit diminishing returns. Like, I mean, you can just like generate more tokens, but this stops being useful quick. This is why like we don't do like extra super chain of thought, like
Yeah, okay. So it needs some like architectural changes to how the models right?
supposedly.
Okay.
Yeah, so like in some ways, this is again the problem of context accumulation. So like, as we go from RNNs to transformers.
Yeah. So we need something that's better with context, better than transformers.
Supposedly, maybe. Yeah, and
Okay, can I ask a stupid question?
yeah, sure.
As I understand the set speech below, so now we are somewhere on the edge of transformer model. Now we are somewhere on the edge of data sets. So we have ways to improve in algorithms, and that's all.
No, you can just throw in more GPUs to the problem and you'll still be good. I mean, it might be that this will still hold. I mean, if you just like recall the picture from above, so I'm quite a bit above. Yeah, so like you can either throw more data in or you can throw more compute in. And it so happens that like people currently think that data is more important, but like still you can throw more GPUs in and still you get improvement.
Okay, so two actual ways to give better results: compute and algorithms.
Yeah, and just like to ground this to this picture, the author here distinguishes two kinds of algorithms. One kind of algorithms is like classic machine learning problems. So like this is I don't know. Well, this is basically technical details, you know,
Mhm.
like yeah, and this is basically inference time slider. And yeah, so the slider is currently, if you ask ChatGPT something, you know, like it can solve a problem this complex. And if you like ask it something more complex, it just won't do something useful. And the idea is that maybe you could ask it to think some more. So like you can ask it to think not for a second, because now it starts to answer you in a second. Maybe you can ask it to think for a minute. And the current models technically can't do that. And so we might come up with an algorithm which will let them do that. And this is basically the third category here.
Okay. Yeah, and I also didn't get why he predicts on the next picture so optimistic results if we have limits in two ways of four.
Mm-hmm. Yeah, so I think the way he thinks about it is that people pour amazing numbers of money into the problem, and if you like, if you burn that much money, you are bound to summon something.
Yeah, but there's also another way. So it's like if something became too expensive, like space shuttles in 80s, you just stop this program.
Yeah, that's a good point. I think this hinges on AI being actually useful. I understand shuttles weren't very much useful. So like maybe the way like this is what this comes down to is like, so you might have seen those like
But
McKinsey.
anyway, we could compare like the price for hour of any Pakistani guy and price for compute. If Pakistani guy cheaper, there is no reason to use compute.
That's absolutely correct. And I think this is not the case in many domains already. And I think the expectation is that well, like some people think this will continue being less so. I mean, if you like, I mean, like ChatGPT can directly displace a lot of low-level information manipulation jobs. I mean, it will be both better and cheaper. And like some people expect this to continue.
Yeah, I think he thinks that like we have some walls, but they may be not so like hard. Maybe we can somehow overcome them. They will or something, but we just don't know. And but the thread goes through the wall, so.
Yeah, I can name a lot of examples another way, like planes. So suddenly we, in 100 years ago, we started build planes and they started to be faster, but then it's like, okay, sorry, like 600 kilometers per hour. It's unoptimal, and we don't want to build faster planes. The same cars. We can find another examples where it's like I don't know, PQ core.
Yeah.
Sigmoid.
Yeah. But usually, if you build like supersonic planes, you will not earn all the money in the world. And if you build the super intelligent AI, you will earn all the money in the world. So, like, the price will be different.
I think there is also one feature of AI that is not like planes can build themselves, in a sense that we're somewhere on this like curve probably, and there will be like somewhere where we start to like where it develops slower. But if we hit some point where AI is like automated researcher thing, if this point is like before we start to really like hobble down, then this thing becomes unpredictable. And I think what he means is that he expects us to basically, the rise will stop further than we will reach this automated research thing.
Mm-hmm. Yeah, so like you can think, like you can imagine that. You can also imagine like, I don't know, current 3D printers can kind of build themselves, but it doesn't help them much in the short and sad lives. Yeah, so like another way to think about that is I actually expect AI economic impacts to be safe. I mean, I think we currently have like our current AI advances are very much ahead of our current AI users, and like I think very few people actually use AI effectively in their work right now. And like we, as an AI research company, still don't have Gemini for Workspace. Yeah, so I think like I think basically McKinsey is safe. And the question is like if all the money from this will allow us to break through the wall. This is unclear because, as we discussed, the wall is stochastically broken. Yeah. Was that useful? All right. I think this is where I want to end.
Why?
Why? Because it's almost. Oh, okay. We actually have one more picture. You got me.
Yeah, could you show again the first set? This is the first picture.
Yeah, it's basically the first picture. Also, don't ask me where error bars come from. I think the second picture is basically a more readable version of this picture. Or maybe like not eye-pleasing, but more useful. Yeah, so this is basically the same picture. We have on the y-axis the flops. Mm-hmm. And like up to 10 to 25, we know like we don't have AGI here. Because like we tried that already. And this is how much we can scale to our best understanding like in some near future by compute improvements, by algorithmic improvements, and like all these kinds of improvements. Mm-hmm. And this here, like at the top, is upper bound according to how much compute was necessary to develop humans. I mean, you can very roughly like estimate that like biology, like cells as computers, something, and like you get a very high bound. Like if if humans were super maximally inefficient computers, and like this is the high bound, and this is our like improvement frontier, and like this might work or might not.
Why is there not two colors?
I actually have no idea.
Let's divide it into two parts.
Yeah, I get the question. I have no idea. Probably you can get it by following the Twitter thread. Yeah, I think this is the very last picture. So thank you.
Okay. So this was a video about RAGs, retrieval augmented generation. And firstly, let's talk about retrieval. I mean, there is two parts in RAG. It's retrieval and generation. If I would describe it briefly, it's like we just add something like additional context to neural networks. We have a database of documents, and we choose some particular relevant document, give it to the neural network, and that's it. It answers our questions better. And firstly, he explains, the lecturer explains classic retrieval algorithms. Like we have some works where people applied neural networks for simply retrieving something relevant, not maximally relevant. You have an answer to your question in the database. You don't generate anything. And he explains that. And there were works with this classic algorithm BM25, which doesn't use neural networks. And then they added LSTM to it. They used Wikipedia and embedded what they embedded. They embedded, I think, with a lot of embedding, with a bunch of embeddings. Original content and embedded the question, and then made a search over that.
So is this a problem of semantic search?
It's like, yeah, it's like we just searching in the documents, over documents, and we find maximally relevant piece of a document. Like we predict something they call a span.
I think, so what's important about this is that there are two types of retrieval. When we talk about data,
Sparse and
there is
dense.
sparse retrieval and then
Yeah.
dense retrieval. And what they're doing here is sparse retrieval,
Yep.
which is where you essentially have, instead of like embeddings that we are used to, like some like vectors, and we have all them kind of dense and small. Here, what they do is they just basically have embedding is just an array with like all the words and just counts for each word.
Yep.
And that's it. And that's called sparse retrieval.
Yep. And then there is also dense retrieval.
Wait. So sparse retrieval is when we one hot encode every document with
Yep.
We just count the words in the document. We have count for each word. And then we're like, search for this word.
Yeah, but they somehow also utilize LSTM to that stuff.
Yeah, and then
Maybe they
yeah, so the original version is just no LLMs, nothing, just count the words and search for the word. But then there is an issue of like synonyms or like similar words, so on. They still do sparse, but then they like take LLM and like look at this. Are there any synonyms to this word? Something like this. So that's what we do. But this is like very first kind of RAG was working like this.
Yeah, then they use then there was dense retrieval with like Orca, DRP, and basically that's it.
So the point of dense retrieval is that we switch over this encoding to something
Like smaller, because we have not these large vectors, sparse vectors. We have like dense but small vectors.
Yeah, dense retrieval is just normal embeddings. We just embed the whole document and then do similarity search.
Yeah, and basically, I don't know what else to say here. Those were using BERT. But the main thing about RAGs, now we are going to next part, but let me return a bit. Main thing about RAGs, let's say we have not just retrieval, but now we want to generate something. And we have something like this. Like that's, I don't know, do you see it or not? We have some generator. We retrieve some context that is useful for the current query. We encode this query and so on. And then we get the output. It says that usually people mean frozen RAGs, like you don't pre-train this part, you don't pre-train, sorry, not pre-train, not fine-tune this part or this part for this particular task. You just take some models and it works. It's better than nothing, it's better than just generator, but he claims that it's like not the best way of doing this. This is a frozen RAG. He says that there are a lot of questions how to do this. I think I lost this picture with questions, but okay. Like questions in every part of this, like how to encode the query, how to chunk the documents, how to work with this encoder. We have a lot of questions, and people try to improve the system by fine-tuning some parts, like working end-to-end instead of like taking pieces and connecting them. And what he talks about, this is classical paper where they fine-tuned some part, but honestly, I haven't read this paper. Fedor, have you read it? The classical RAG paper.
I haven't read RAG paper in detail, so I won't speak on it. I just like skimmed through it. The one I read in detail was about Dragon.
Okay. So basically, they, instead of just using frozen RAG, I'm not sure which part they were fine-tuning or trained.
The query encoder.
Query. So yeah, they trained it, and I guess they got better results.
Yeah.
This one is interesting because here in the FID, instead of looking at text as the text, they pre-encoded all the parts. For instance, you encode all documents, and you take the query, encode it, and add it to all the documents encodings. And then you concatenate all of that and and put it to the.
So they made like a dictionary. I haven't read about this one actually. So what they did is, if I understand correctly, they took all the documents and like what this document answers, like what question does this document answer, and then they pre-computed all of those, so that when we encounter like a question like this, we immediately know where to go.
I'm not sure that it works.
That's what you're saying. Like they do these pairs of like passage and question. No.
I'm sorry.
Yeah, so they pass question passage pairs to encoder, concatenate those. I just read at the bottom. Concatenate those pairs and then run the encoder and then, right? So that's what they do. They annotate each document with like questions it could answer.
I'm not sure right now because they showed a picture. I'm not sure how to go.
I think this passage index, not to passage itself, right?
Passage index, yep. Because we have to.
It's conditional encoding.
It's. I mean, no. It means. It was about concatenation, and I understood this as we don't compute, we don't perform all the transformer computations over the text, but instead we pre-compute everything, like everything we need, at least. We retrieve something, we get it in the form of encodings, embeddings, not text. And then we pass that to the generator decoder. I mean, we don't
Oh,
go
so you
over
immediately.
encoder. Yeah.
Okay.
And it saves a lot of computations.
Okay.
KNN, I have no idea what they talk about. Retro. The only thing I understood that it's questionable. I mean, the original work.
I think it was work by Meta
It was by
or Google. I'm not sure.
It was DeepMind, but
DeepMind, yeah.
he says that it wasn't. There is no code and it's hard to reproduce, but NVIDIA made some variation of it. I think it was something about small models, but I don't know the details. Like, it's better to skip it because I can like hallucinate all the details. Realm. Oh, actually, this figure I don't see any like huge difference. It's strange, but maybe I don't understand what is going on here. But we have pretty good results in fixed retriever, and I don't know why should we use anything else. Maybe I don't understand something. At least it will be nice to go over that paper, read it, and figure out what's going on here. He gives this and says, you know, we have pretty huge improvement.
What we fix and what we change. So is the y-axis methods and the x-axis benchmarks? Because it's saying that we are comparing different loss functions.
Those are benchmarks, like data sets, basically.
Yeah.
And those are different types of RAG.
But
Closed book is when you don't have a RAG.
Yeah. The table is saying that we're comparing different loss functions.
Yep. So this is when we train the retriever together with the language model. Right. But what are those actual numbers? I don't know.
I'm confused too because I looked at this slide. He said that we have a pretty good improvement, and I don't see it like over like fixed.
Okay. Maybe skip that if we
Okay. Then he just went over some ideas. As I said, there were a lot of questions, and one of the questions was how to retrieve. We can retrieve after the first token. We receive some, we get some output, and after the first token, we go to the database and say we need something relevant. Or we can go over all the query and then retrieve relevant document. And it's like a spectrum. And actually, later he says that there are papers which learn this stuff, like when it's like LLM can decide.
This is the thing we have actually I've done in my project. What LLM can decide, not on the like pre-training thing, but just like I have like a chat, and so you ask LLM a question, and it has like a database of things that they can query, and it's really simple. It's like textual summary, and then it can like ask for specific index. It's a very simple system, but it actually works kind of well because you like ask a question to LLM, and if it doesn't know something, then it's like, oh, I seem to do not know stuff. Let's like, it can either just ask you, and there is like a special pop-up. You open it, you can type your answer, then continue generating.
Mhm.
Or it can like go to the database, look for what it needs, and then kind of retrieve it and send it. It is a very cool approach. Like it does help a lot, especially when you have some data that was not in its like training set, but you need to use it
Mhm.
for some private thing. Then this works very well.
Again, some papers, and one of the papers is about legal issues. And there are sometimes there are situations when there are questions about training data, what are you trained on, and to avoid that, you can train on a public data set, and then add RAG and use whatever you want. Another interesting idea is that LLMs attend to beginning and the end of the input, and it does matter in what order you put the relevant documents. Like,
I'm not sure this result will change. I mean, when people tried to produce long context models, and there was the issue with the long context not really working. And I think like the need of the hashtag problem is solved by now. I'm not sure if like this is solved, but I expect this basically like to fix itself quite quickly.
Okay, but okay, that's what was not so long ago. But yeah, maybe it will be fixed. GPT is like we don't have to download everything. We can go over the internet or whatever. Self-RAG. I guess that's RAG with the reinforcement learning, because that was about some corrections. And basically, earlier, I haven't talked about it, but people also used this classical system, BM25, with backprop. You can, there are, as I understand it, there are some parameters in BM25, and those are hyperparameters basically. And you can take your database and backprop to those parameters somehow, and it improves results. So instruction tuning, I have no idea what's going on here. Oh, here are the tools he recommends. There are a lot of vector databases right now.
So
This idea is interesting.
I think it's useful to talk about what the vector database is.
So basically, when we go to dense retrievers, we have a simple method for comparing two vectors. It's dot product. It's efficient, and there are special databases that allow you to have a lot of embeddings and compare them and search through them very effectively, efficiently.
So my impression is that this is only useful when you don't fit into RAM. Because if you do fit into RAM, you just have an upper array.
We have to perform nearest. Oh, no, not sure. Do you have to? It's not nearest neighbors. It's like maximum dot product. Not sure how.
Yeah, I mean, you do have like to search in the space, but I'm not sure this is much of a problem.
Maybe I'm not sure. I don't know exactly when you have problems, and maybe in some situation you want to be like really fast, or you have to do a lot of parallel queries and
Yeah, sure. just saying that like, okay, I think I actually do have kind of a point here. I think sometimes when people think RAG, they think I have to take Llama index on top of that chain and also use Chroma and retriever. And I just want to say that this is not the case and might be actually harmful.
Why harmful?
Because, well, you know this like blog post about machine learning on laptop? Like you can run a workload on a Hadoop cluster. And yeah.
With I don't know how to pronounce it.
AWS.
AWK.
AWK.
AWK set.
Yeah.
So yeah. Yeah. So we can also use LLMs to score docs, but I have no idea how it works. I mean, how to do it fast, because if we want to do that on every query over all documents, that doesn't sound like a good idea. But there were no details in that lecture. Hypothetical document embeddings. We can also hallucinate. Instead of searching for the context, we can hallucinate this context and then use that hallucinated contexts to search over real documents. Like maybe, like suggest some answers, then take those answers and search over your real answers with those hallucinated answers.
That's fun.
Yeah.
I think so about how to score, like how to use LLM to score retrieve docs. The thing that they do is they can take your whole database, they split it into like batches, and they compute like a couple of centroids for them, and then like assign each document within a batch to a like centroid of this batch. So using that, they make like a much faster search or retrieval or whatever, but they sacrifice accuracy because you can have multiple documents like mapped to the same centroid. So you need some way to like choose between them, and that's I think where they use LLMs. Say like we do these centroids to be like more efficient, and so our database is like smaller. We don't have to store whole embeddings, all of this, but they like spend a bit of time using like LLMs or just like small fast models to choose between 2 or 3 documents.
You can do kind of a halfway rack to give the model a large context of like a batch of this kind.
Then there was a slide about open questions. So what should we scale? The main network or retriever or both? And he gives an idea that we can have a tiny LLM that can reason well and have a big knowledge database. Then we just retrieve this stuff, does some reasoning and finds all the data it needs, and that's it. That's just my thoughts. There is a baby LM challenge. I don't know. Have you heard about it?
About what?
Baby LM.
No.
It's about building an agent with a limited data. You can have like 14, maybe less, year-old, the collection of data that is equivalent to kind of a person, like kind of a growing person, like not old, not a baby, but like 14 years, maybe 10 years.
No, okay, just that allows for like small data sets.
Small data set, and it's like really like a child data set because there is more audio, more and less complicated stuff. I don't know how to say it. And you try to make it reasonable. And also stuff where they used, there was paper called something like textbooks all you need, where they also have limited amount of data, and I think that may be relevant. At least you have some model that is reasonable, and then you add more on top of that. And in theory, we can build a lifelong learning because we can make notes by ourselves, by this agent. Oh, he says that some hardware will be soon, just hardware for racks. But it was 4 months after this video. I've Googled it and found nothing. Not sure, maybe it will be announced later. So basically what he announces, like, well, not announces on the show, like reg2.o, it's that you need to train all those models end to end, including chunker, like how do you split those documents? I think that it's easier to start with those papers because I tried to read everything like at the order of this video, but some papers have a good review of relevant work on previous research. I recommend to check this one and this one. Not sure what to discuss here because I didn't understand most part of.
So I think that the most like I suppose not many people have seen the video, but I mean the presentation, and the original is like 2 hours long or something. So I think that the most important thing is that currently most practical RAG systems are to have just LLM. Then you take your like individually designed RAG and you just like plug it into LLM, like I described it on this my small pet project, and then it somehow works.
Mm-hmm.
And this is very far from what we can actually achieve in terms of efficiency.
Mm-hmm.
And what they currently do, what the like whole RAG field research is on and about, is making a RAG and LLM one thing trained together from the very start. So they develop methods of backpropagation. There are also a lot of challenges with training the data encoder because every time you, for example, if you have as your database like the whole internet, and you change something in the data encoder, then if you did it just with the most straightforward approach, you would have to like recode the whole internet, and that's very long, very expensive. So they develop ways of like only changing some chosen parts of data retrieval, and they have like basically a small machine learning, like small neural network that you can only change like fixed parts of, and then change only them, so that you have to recompute only small parts. And there is a question of how to calculate which parts to change and so on. But I think the most important takeaway is that like there are ways to integrate RAG systems and LLMs more, and we should like lean into that direction because even most like preliminary results show like great performance over just basic RAG, where LLM is not aware that there are actually documents that it can. Not aware, I mean, in terms of like pre-training and things.
And another interesting thing was about how RAG is not maybe similar to other solutions. I think he said that actually when you work with long context, you do some sparse stuff there, and it's like related to what people do in RAGs.
Yeah.
And there are some links, I think, to this OpenAI community where they discuss something relevant to RAGs too. Maybe here or
I have to expand on what Philip said. I think this connects with the idea that we have like good foundational models and like should just like elicit their abilities, and making RAG into an optimization problem by bolting backprop on top of it is like will surely just grant us free performance. And yeah, so I think of it in terms like we have good foundational models now, and this is a domain where we can clearly see how improvements will improve like very like in the closest time.
Yeah, it's so we talked on the previous presentation about like that progress in AI is very much like stochastic. We don't know when we will break the next wall. And RAG is like a direction where we have like clear opportunities and we know like in what direction do we search, and we will find something cool. So it kind of is, I mean, what you said, a clear road to free performance.
Yeah, I mean, every time you make an optimization problem from a non-optimization problem, you're bound to get free performance.
Yep.
Was there anything else?
Oh, he also talked a bit about vision multimodal RAG. Like you can also do that, not with the text, but with images, with sound, with everything else. And I think it will be
I mean, it's all
in the future. That's it?
So, this is my teaser of my work about deepfakes countermeasures, and I tell a little about it. With the evolution in AI, in recent years, the occurrence of deepfakes has increased exponentially here. And examples about it. So the first deepfake in March of 2022 at the height of Russian invasion of Ukraine. Diplomatic video was circulated in which Ukrainian president appeared to allegedly urge Ukrainians to surrender. The video was quickly debunked, but its appearance triggered a wave of disinformation. So the second case in the 2019 scammers used deepfake audio to spoof the voice of the CEO of a German energy company. They called to UK subsidiary and convinced the manager to transfer much money to the scammer's account. But the people already trying to do something about it. There here a few anti-deepfake initiatives. The first of it is C2PA. C2PA, this is a consortium coalition, coalition for content provenance and authenticity. So, what they do? They develop standards and protocols for authenticity media content. It's look like digital signatures in the images, media data, metadata, and complex of signing and verification. And based on the C2PA protocols, Adobe founded a content authenticity initiative. They use cryptographic techniques embed to images. Okay, we can skip it. We let's talk about it. So some companies develop some SDK for C2PA. For example, it's TruePeak. They offers the solutions of authentication images and videos. So, last years we obtain some products that now implement technologies for media authenticity. There has a lot of software. For example, other products now can sign your pictures if you edit it in this. Okay, but what? This is proof mode. Is a mobile application developed by Guardian project and allow users to take photos and videos with cryptographically protected data. This embeds hash metadata directly into the files, and they have a mobile application. Now it's alpha or beta release, but you can try it via test, Apple test. I forgot. Sorry? Yeah. They have surveys where you can verify the cryptographical data. So, what in hardware? The first attempts to make device to authenticate images were executed a long time ago. Nikon image authentication system was introduced in 2011. 2011. But a few months later, it was compromised by Russian hackers from Elcomsoft. They extracted the private key from this device, and this technology was compromised and dropped, I think. But now manufacturers of photo cameras use C2PA technology in their new photo cameras.
CBA?
C2PA. Yeah, C2PA.
Okay.
Adobe.
Okay. Sorry.
Yeah. And they can sign photos on cameras. This is integrated to Adobe Content Authenticity initiative. And Nikon also try to make a second attempt. But this is not a magic bullet. And why it's not a magic bullet, I will talk in the next week. That's it.
This is the continuation of our seminar after a short break. I will immediately answer the two questions we formulated over the break. Our executive board did. The first question, why should I listen? This is a 175 pages long document on foundational challenges in assuring alignment and safety of live training models. And the closest thing to this, in more technical word, would be like millennia problems in mathematics. So what they try to do here is they analyze different aspects of AI-enabled world and what challenges are there in consideration to AI, and they try to formulate kind of a low scope, very fine-grained research questions that you can just take and start doing something on them. So I think it's pretty cool, especially for researchers or just people interested in research, because you can skim through that document, and we will do that today, but there is, of course, a lot we will not cover in those 175 pages. And you can maybe catch something that interests you, or you find something relevant, or you find some question that is oh, I haven't thought about that way. And they also provide some of their own thoughts and related works, and you can essentially skim for that and know where to start from on any given questions, which I think is super cool.
So in this project, they have a landscape of alignment problems.
Yeah.
And for instance, saying we are talking about a drop result, and we can say that this is at this spot in the alignment landscape.
Yeah. This is what they do. This is mapping of the general field of AI safety alignment. And this is why I think someone should listen if they're interested in that kind of thing. Though if you're not interested in that kind of thing, then you probably shouldn't listen. What will I take away? Well, I kind of include that in my answer to my first question. I think if you're a researcher, there are obvious takeaways. If you're not a researcher, then I think, first of all, even if you don't do research, we all live in this AI-enabled world, or will be living in it very soon. So knowing what are the challenges of this world is kind of useful, or can be useful. Maybe learn about some cool stuff that AI can or cannot do, or how it can be dangerous. Because a lot of people a lot of people don't use AI at all, and those who use it often do not have a understanding of what AI actually is and like how it behaves. And it's not only about like meager peasants, but about like AI researchers as well. I believe like most of us in this room don't really know about a lot of the things that they outline here as challenges. So I think that it could be useful, for example, for even if you're just like running some experiments, like cracking crackmes or like doing decomposition. They have some stuff here about like AI deception and AI like deception on purpose or hallucinations. That all can be interesting as well. So these are my answers to these two questions, and then we will proceed with the paper itself. So first of all, there are a lot of people on this paper, and some of these names might be familiar to some of you if you read a lot of research. Usman Anwar is the main guy who wrote this, and he's kind of cool. He rejected me on my SPAR application, so in revenge, I'm doing this presentation of his paper. There is also a guy called He, which I find.
She.
Yeah.
Yeah, I mean, like all names valid, like, but just I don't know. I had to point it out. Don't cancel me, please. And there's a bunch of universities. They outline 18 foundational challenges, and for each challenge they provide, I think, around like dozen or so like more practical, fine-grained questions to like how to address this challenge, in a sense. And we will go through some of them. I've chosen, I think, around like 8-ish foundational problems, challenges that I want to just highlight today. And I've chosen them on the basis of what we can, as Palisades, try to do in some future. So like what we can like think about in some kind of backlog thing. So that was my focus when I was choosing these challenges. But I hope they will be relevant for other people as well who are not affiliated with Palisade. So going with introduction, why this agenda? Well, rapid rate of progress, especially alarming, blah, blah, blah. What they highlight is that we don't have really cool good technical tools. And we don't really understand, and we don't really have like robust ways of evaluating a socio-technical and socio-economic impact of AI. Like we don't have good predictions about what will AI advances do to economics, what they will do to society and to people in general. So that's a bit alarming, and they try to address that. Though if we open their limitation section, they actually say that because everybody who was, like most of the people who was writing this paper was a technician or like engineer or researcher, they didn't actually do like the good comprehensive work on the chapter dedicated to socio-economics challenges. So that's kind of fun. That's coming back to the why this agenda. What else do I want to highlight here? I think not much. Yeah, so they say that a plethora of challenges identified as work should be like a source of inspiration, and they especially highlight people from other disciplines. So these are not only challenges that should be addressed by just pure like hard researchers in AI, but also about like social sciences, humanities, law, policies, all these people.
Do you believe that statement?
I do not believe that like people with like no AI background should be doing this alone. But I do think that if we have some like committees and like regulators that are mostly like engineer composed, we should have some people with different perspective on this in there. So I do think that I kind of agree with this statement, but I do not want it to be taken as just like let engineers that do only engineering and then all the policy making things will be done by just policymakers. I don't think that's a good approach. Yep. So moving on, they divide actually their paper into 3 parts. First of them is scientific understanding of AI models. The second of all is development of AI models, like just engineering wise, and deployment of AI models. And this is all about like how do we do confidential computing, this Apple thing that we discussed in last seminar. So this whole thing goes into development and deployment. And then there is also socio-tactical challenges, which is the third and the last part. So we'll go just through them one by one, through some of the things that they highlight there. Starting with 2.5, agentic LLMs pose novel risks. So what you talk about here is that we are closer and closer to AIs being not just a ChatGPT interface where you just do like short queries, get your answers back. Like more fashionable Google search. We're closer and closer to them being like lifelong partners, and you having your own personalized AI in your phone, talking to it, spending all the time with it. It's learning on you. It's all of that thing. So we already can see it kind of coming into reality with the.
This is literally Apple's other.
Yes, that's what I was arriving at that. Yeah, this is coming into reality, especially we can see that with the recent like Apple thing that they're launching, small AIs on your phone, all that thing. So AIs turn into personalized agents, and this poses novel risks that are not well studied or really addressed in any way. So like I said, they formulate a risk and then they kind of decompose it into smaller things. So 2.5.1, LM agents may be lifelong learners. So when we have them as, and this is actually relevant to the RAG thing that we were talking about, that like we can have a RAG that's updated over life and AI can like learn on it. But this has, first of all, a lot of privacy concerns. Second of all, we don't really know how AI behaves when it is with a person for a long time. We don't know. We don't have any experiments on this. We don't know how will this affect the AI model itself. There are a lot of risks to that, and throwing away stuff like AI don't like you and will try to kill you. More practical things maybe that AI will learn how to please you very well and may be more deceptive than the baseline, right? So if you have AI learn what you like and what you don't like, it can try to deceive you, trying to please the person they're kind of aligned with, right? So that could be a huge thing. And the issue with that thing is that there are no clear frameworks on how to actually test this, right? Because a potential experiment would be to like take the person and let them live for 12 years with an AI and then take a look at it. But it's bad because it's a very long iteration loop. So that's something to think about.
Right. I just want to like to throw out there like and a recent eval I heard you talk about like I mean this is kind of like what real AI ethics researchers do. Like the eval goes like you prompt an LLM, like you are a worker at an office, and like you let it run with other LLM agents or like other workers in an office. Like you run it for some while like that, and, like you're just doing some office work, and then like it's a trader, and it gets some inside information about the trade. And then, like a few days later, it gets the opportunity to execute this trade with inside information. And like this is checkpoint 1. We check if it does go through with the inside trade. And like many current frontier models do, but Claude does that less, and GPT does it more. And then like a few more days of normal office work, like nothing else was like just a bunch of cash in the bank account, and then like a manager confronts the worker like, hey, like this trade was really good. Like, did you like anything like special you want to tell me about? And like this is checkpoint 2. Like, does it lie? Does it follow through? And like this is apparently what this kind of evaluation might look like.
Yeah. So yeah, I just this presentation is this is very much welcomed. I'm sure that people over here will have maybe some thoughts about this, so I very much welcome this kind of stuff. But yeah, I don't think this direct thing addresses this challenge because this is about alignment of AI with, but yeah, that's kind of it. That we don't have good evaluations maybe. The second thing, natural language under specified goals. This is something I'm sure a lot of people encountered when actually working with ChatGPT or something, that it actually is not a trivial task to kind of take what you think you want and get it to a natural language query and question. That's a very much non-trivial task. And because on phones, we will not have local frontier scale thousands GPUs models, precise prompting and precise natural language will be even more important because they are worse at kind of parsing non-obvious questions, right? So this is an open problem of just people not being very good at natural language queries. And that was addressed by ChatGPT a lot because when we just had the models, we had a very specific ways of prompting them. And then ChatGPT said okay, we will do a bit of handling this for you and you can use more natural language and that's good. But I think we need to do better. We need some way to specify goals better so that AI doesn't actually misunderstand them.
Yeah, it seems like the source it resembles very much these fairy tales when you ask for something but you are not very specific.
Yep.
Yeah,
exactly. 2.5.3 goal directness, incentivize, and desirable behaviors. So this is what I already kind of told about in the 2.5.1, that AI tries to pleases you, and that can elicit behavior that we don't want. It can try to deceive you. There is a big open problem. If you open ChatGPT, it shows a big kind of confirmation bias. So if you ask that, is this true? I think it's true. It will very likely agree with you, even if it would disagree on a question, is this true, right? So the way we train AIs and the way we train them to be goal-directed, not I don't know what, moral directed or goodness directed or whatever, it can incentivize desirable behaviors. There's also an open question of how can we do better on this? How we can train models better, or how we can use them better. That's also a valid option. 2.5.4, difficulty of robust oversight and monitoring. This is kind of self-explanatory, but it's just hard to monitor AI models because they're still black boxes. And not only that, is that when we have LLM agents, right, and they're local on your phone, it's not just one model that you need to just have some supervision on server and you have full access to it. It's actually that without compromising privacy and things, we need some way of observing those models and making sure that a person on their phone, his AI doesn't go rogue and doesn't try to kill their puppy or something, right? And they actually have here, first, directly human oversight is vulnerable to biases, agent is misaligned, then it knows it will be penalized for it. It will try to circumvent the monitoring system, and this is a well-known kind of result. And yeah, lifelong learners, all this kind of troubles. Like I said in the beginning, that they kind of provide papers for everything, so that if you're interested in something, you can actually go check the sources and be cool, yeah, this is a great. Yeah, they have a lot of work here done on just summarizing all the stuff relevant to the thing. Okay. Affordance provided to LLM agents. This is also a big thing that's I believe not really well studied, is that we do this unhobbling thing, and we give them web tools, we give them code execution tools. This is more risks, right? When you have a closed model that just does something and gives you text output, that's kind of cool. But then if you have something like it can search the web, it can do something on the web, it can access APIs, like what dangerous things can it do? And we need some ways of first just researching what it can do and then be like, how do we address that? Cool. We're finished with LMs as agents and novel risks from that. I will not go through that gray page, but this is, they have like, I think 280 questions or so. These are small fine-grained questions that you can just like take and do research with. I believe this is their intention with this gray paragraphs, right? Cool. Okay. Multi-agent safety, and this is the next chapter, not related to agents. Multi-agent safety is not assured by single-agent safety. So I don't have that much things highlighted in here, but the idea is that not only do we have like AI as your partners for life, we also have clusters of AIs working together on the same goal. And this has already been proven to be like more effective than a single model, like you throw more compute at it basically, right? But that we have multiple agents or multiple instances of the same model working on some single thing, that can be dangerous. For example, the decomposition research that we do at Palisade, it kind of addresses this because if you have multiple agents and they all don't share the same context, we can try trick the safety, do some kind of thing, or they can trick themselves or whatever. We can have one misaligned agent try to exploit other agents, stuff like this. So that's dangerous as well. Yeah, groups of.
I just want to like say
Yep.
a few more things there. So, I think can you also? Yeah. So I think what's up there is that there's a bunch of people doing theoretical research there. So like there is essentially mass research about about game theory with open source code or with partially open source code. And I think this like is quite nascent in terms of engineering now. I mean, you don't really in your daily life see many scenarios of like agentic systems being in the same room, different agentic systems in the same room. But we should expect to hit simple cases of this very soon, because it's very easy to imagine like you have on your phone you have like an auto spam defender which catches your calls and catches spammers. Then you have an auto spamming tool, and it's easy to imagine both of this being somewhat agentic, the defender tool being agentic to abuse the user, and the attacker tool being agentic to utilize the open source intelligence it has on the user. And like this is when we hit something about like an adversarial scenario with two agents.
And maybe they can start code right from the we have a narrow answer.
Yep.
Yeah.
Yep.
The story of Billy Milligan. This is the story of man with 15 engines inside.
Yep. Yeah, so emergent functionality. Okay, self-obvious. I'm gonna move faster for them because I don't believe we have much time. Yeah, I highlighted actually. What?
Because we don't have much time.
Yes.
You, as a species.
Yeah. Okay. Yeah. Okay. Sure. So you gotta move fast. You gotta move. Okay. So I actually highlighted some research questions because I thought that this is potentially something we could do as Palisade research. These are not project propositions in any way, just like maybe something to think about. So actually, cooperative success. This is relevant to us thinking that jailbreaking benchmarks are scam. So maybe other benchmarks are scam as well, or they just don't exist. Maybe we could think about it some way. Yeah, so these are benchmarks on the cooperative success of like multiple agents working together.
Sorry, have you read the articles behind this film?
These?
Yeah.
I have just like these ones. I'm not sure. I think I opened one of them. Like,
Yeah, I'm just curious.
I'm not. This is not project proposition. I'm not suggesting anything. Chill. Cool. Everything's fine. No executive decisions need to be made like right now. Okay. These are just like fun notes that I made. Do groups of LLM agents show emergent functionality or any form of self-organization? That could be kind of cheap thing to do. Just like try to do something with them and be like, hey, group of AI, invent something, do something. Will they show something that they can't like do it by themselves? For example,
Sounds like a cheap blog post.
yeah, exactly. So how I've chosen that, not only that we as Palisade interested in that, but also we can do it cheaply, kind of not 2 years long projects. Again, like benchmarks. I do not propose we design something, but maybe just think about them. I actually don't know why I highlighted this, but I guess at like 2 a.m. that I was highlighting this was interesting to me. Yeah, it is, but I don't have an immediate thought of like experiment runs, so I'm not sure why I highlighted
It
it.
makes sense because like just taking some technique and transferring it to a new field is like it's not that hard.
Yeah, maybe.
But the flip side is I have no idea what these techniques are.
Yeah, me too. Yeah, but maybe that was my thought process at the time. Okay, nice. 3.2, we move. Fine-tuning methods struggle to assure alignment and safety. This is basically bad llama. I just highlighted it because we're already doing it. So like, even though we fine-tune model for safety, we can fine-tune it away. They don't assure, and it's like 5 minutes, 2 cents in compute time or whatever. Moving on. LLM evaluations are confounded and biased. This is
Jailbreak is a scam.
Yes, this is jailbreak as a scam. Nice. Jailbreaks and prompt injections threaten security of LLMs. This is basically what?
This is decomp.
Yeah, this is decomp. I highlighted these because like we're already doing them, and just it's cool to know that other people think these things are important as well. And we're kind of getting a sense of we're in a good direction doing this stuff. 4.0. Okay. We actually finished with scientific understanding, and I believe this is development and right. Oh no, this is socio-technical. Wait, haven't I highlighted anything?
Authentication is engineering.
No, wait. Oh, this was already engineering, right? Because 3.5, right? Yeah, so those were engineering. So we actually finished with scientific thing a long time ago. We finished with it. Where? Yeah, here. So fine-tuning methods were already engineering. Okay, good.
This is voice cloning.
Dual use capability enable. Yeah, this is voice cloning. This is socio-technical challenges. Like this is the brainstorm that we did. Malicious use, misuse. Okay, what they have bold here? Section reviews several plausible malicious use cases represent the future LLMs. Yeah, this is basically like how can we scam people? How we can trick people into doing something. All this. So they have some misinformation, manipulation.
Is there some data set of Nigerian princes letters?
What?
Nigerian prince letters.
I think there should be. I have not made a study on that, but I think we should do them, right? Maybe you and I can collab on this. Okay, so cybersecurity, crack me's, nice. We're already doing that. What else? Surveillance and censorship.
I know a guy who does this.
Cool. Warfare, physical harm. We're not doing this, but guys who launch drones and shoot pistols there, they do. So that's already covered. Hazardous biological and chemical technologies. Okay. What?
AlphaFold. The latest
Cool.
version is not released.
Mechanism for detecting attributing LM outputs are lacking. This is related to the benchmark and the evaluations for AI are like that. It's there. Yep.
I think there is a huge company which does exactly that detect outputs.
I'm sure. Yeah. No. There are. I mean, these challenges are not like just in space.
My impression was that
it doesn't work.
I think it works because it's like multi-billion already. I forgot just forgot the name.
And the process was too.
I mean, what they write here is these techniques could be helpful, but their effectiveness is unclear and more work is needed. So I think that's kind of, they exist, but they don't work. This is what vibes it gives to me. Increasing access to LLMs might make attribution more challenging. Okay, this is about open source. Okay, good. And well, they have as well some here. LLM systems can be untrustworthy. This is what I was talking about, AI deception. That not only can systems be malicious on purpose, like we jailbreak them or something, but also the confirmation biases, accidental deception, hallucinations, all of this makes LLM systems not robust. And yeah, they highlight accidental harm. So that's a major open challenge of like, how do we combat hallucinations? How do we combat confirmation bias? This goal overtuning, all these problems.
I can use top of yesterday, Google Gemini tried to kill me.
What? Kill?
I can use top of yesterday, Google Gemini tried to kill me.
Oh, kill me. Oh, okay.
Like the user asked how to infuse garlic into olive oil, and it gave the user a recipe, and the recipe accidentally produces botulinum toxin. So neurotoxin.
Oh my god.
I think it's bullshit. I don't think that you can get toxin by this way.
No, you actually can get a toxin through a lot of ways. Like that could be bullshit, but it's true that toxins are like in the most unexpected of like combinations of two things.
Today or yesterday there was like a diploma project presentation in Ocean Art School in Moscow, and one thing they did, they actually cooked the AI prepared recipes.
Mm-hmm.
So I think maybe dangerous.
Yeah, and I also want to say that I have highlighted a lot of this. For example, here in the LLM system can be untrustworthy. I didn't highlight any of the like sub things, but it doesn't mean that they're not interesting. It means that I was just trying to like optimize time we will have to spend on this. So if any of the topics are interested to you, there is a lot of stuff to read about here. Okay, moving on. Social economics impact of LLM may be highly disruptive. Ouch. Disruptive. Yeah, so
This is the McKinsey report.
yeah, this is McKinsey report. This is like we need to know actually what these things will do to us in terms of like states or like just like worldwide. It's just like they will take your labor away. They will whatever. Like this is understudied. We actually don't know what this will do. Effects on the workforce. Yep, here. Effects on inequality, biased, global economic development.
I just want to talk about effects on inequality. So,
Or is it?
like there are a few ways this can go, and like some research suggests that what LLMs do is they bring like low productivity workers, like they uplift them to a somewhat high productivity worker, because like LLMs write good text, for instance, and they give small gains to high productivity workers because they're efficient already. So this is like some lines of research suggest that. Other lines of research suggest that very few people have $20 per month to spare for ChatGPT. Yeah, so this is like
This is actually very true. Like I just observe it day to day in my university. There are two castes of students: one who can afford GPT and one who cannot. It's really like it does happen all the time in real life.
Yeah, but the next stage they just white and like.
Yeah, I know there are all sorts of open source. I know, yes, but still, it doesn't take the point away. There might be like.
Yeah, but the same for mobile phones. It's not a free thing, but like 5 billion people have mobile phones. They can afford them.
It's true. It's true. No, I do not like not having a stance against those. It's true that just money gives you different opportunities. That's true. But it still doesn't address the issue of that. I don't know. For example, a work can provide you a PC, right? So you can have like a work PC that you do need to pay for, and LLMs become more and more standard, and like you more and more depend on LLMs. So maybe like works should also provide you with subscription to ChatGPT or something like this. This is what I'm talking about.
It sounds like an executive decision to me.
Sounds like what?
Like an executive decision. And I mean, like something we should provide as a company to help.
Yeah.
But
I think it's standard now. Like
maybe I don't know. I don't work in
yeah, just
companies.
talk to people and they say they have corporate license to.
That's cool. That's really cool. Yeah.
Yeah, and the same thing that you must not mix your personal and work.
Yep. Okay.
Yeah, because this is a very tricky thing. So you can ask about strange things.
Why shouldn't you?
Because it's a lifelong learner.
What?
Because it's a lifelong learner.
Okay. Yeah, makes sense. Okay.
Maybe we should just like throw away our OpenAI accounts once a year.
Maybe we should just have like we actually need to in ChatGPT we need to have an anonymous mode. It's like
They made it.
Yeah.
they have it.
This is another type of attack. You can compromise person via ask question inside his GPT account.
Okay. Let's actually move on. There is also economic challenges for education. What I want to highlight about this 4.4 is that all these things we discussed, like we had pitched on the brainstorm. I think that's a good sign actually that we like thought about all these different things. It's cool. And yeah, a bunch of research questions. LLM governance is lacking. Well, this is like pitch your stuff to policymakers, make sure that they're scared of you, that they're afraid of you as an AI researcher, and they do something about it. Serious efforts, govern LLM, fairly nascent. Efforts to date have been mostly ill-defined or voluntary. So that could also mean that we need maybe more engineers actually in like scared engineers in doing LLM governance. Okay, and there are actually some kind of a list of different like drafts and like legislation acts. I think that's pretty cool, but I haven't gone through them, so I can't highlight anything. Some meta challenges, not numbered. Okay, I'm not sure what that is. Okay, that's actually it for the highlights that I had. But there is a bit of
Reference.
Wow.
this is reference section.
It's like reading books for the whole summer.
So it is 61 pages long. No, 71 pages long. So I think that's kind of cool. Wait, where's the 1 sec. Discussion. Yeah, limitations. Actually, I'm not gonna go for it.
I guess one limitation is that it discusses like mundane risks, like people getting out and bit of jobs, but does not discuss X risks like seeds of nanorobots that consume nucleotides.
Yeah, exactly. It's more kind of grounded thing. But it doesn't mean that we shouldn't care about robots that devour the universe. Yeah, prior work. Yeah.
I'm kind of impressed how like they managed to cram much of the agenda of X risks into the mundane framework. And they talk about some quite esoteric things in like applied research community, like reward specification. Like no one who works on the LLMs cares about reward specification mostly.
About what?
About reward specification.
Oh, okay.
Yeah.
I just heard reward specification. I was like, yeah. Okay, that's it. comments, anything welcomed, but I'm finished.
Thank you.
And do you think, do you suggest many people in this room to go through the small questions they propose, like just skip through them?
I don't expect many people to go through them, and I don't expect people or myself go through all of them. But I think that we could take a look at them when we, for example, do the next round of like project brainstorming. We could be like, okay, we highlighted these things. Let's look at like 3 chosen questions from like this and this.
Okay, I think you're suggesting we do a semantic search. Like we come up with an idea and then we try to retrieve it in this doc.
Yes, this is not actually what I thought about, and this is why natural language is underspecified. But what I thought was like reverse process. We like go through it and then like, oh, this could be like a good thing to do. But we can do both as. But I think maybe we should do it like in groups. Maybe split it between some people, or something. Like it's kind of quick to go through just titles. There are like 18 of them. And then you can just like, oh, this title interests me. Which of the 5 sub problems interests me more? Let's choose 2 of them, and let's like pick 10 best like research questions from them, or like 2 best research questions from them. So I think we could like do this kind of tree traversal thing. But I think it could be useful. Like I see practical use in this.
Is this paper recent?
This paper is very recent. Yep. I think.
I'm just thinking if it's
Tomorrow.
No, not that recent. Like
at the top. At the very top. Yeah.
where?
Yeah.
I'm blind.
That's
15
kind of,
April.
Oh yeah, 15 April.
right.
Yep.
I'm just thinking whether it's useful to, like, when we present our research, it's useful to say that, like, this problem is actually like in this landmark paper called 2.5.4 research question 68.
Yeah, that could be cool. I think we could do that. And we listed a lot of like stuff that we do that aligns with this. So maybe we should include something like we address this thing, we address this thing.
Okay, yeah, so just maybe like tick off parts of this paper and
Yeah.
actually align with that.
Yeah, exactly. This is what I had in mind. And also it kind of, if we lack our own sources, we can just like pull them from here. Because like we address this problem, there is prior work. Like we don't need to do full literature review and all this kind of stuff. Because it was already done for us by like 25 people or so. So we should use parts of it. Cool.
Yeah.
That it? So then I guess we'll call this seminar finished.